How to read a motor nameplate. Found on all types of electric motor, the motor nameplate provides information about the motor's construction and performance characteristics. Whilst motor standards are established on a country-by-country basis, most motors fall under the two main industry bodies, the International Electrotechnical Commission, IEC, and the National Electric Manufacturers Association, NEMA. And their nameplates adhere to the standards set out by the body. Understanding how to read the nameplate of a motor can help identify faults more accurately, ensure that the right motor is being used for the job, and can result in a more efficient service from a motor repair company if there is a fault. What information can be found on a nameplate? A nameplate contains a large amount of useful information relating to the motor, including the type, RPM, frame size, and power of the motor. In this example, we use the nameplate of a W22 Premium 3-phase electric induction motor manufactured by WEG. Whilst the exact layout and format of the motor nameplate will be dependent on the manufacturer and what standards are being adhered to, IEC or NEMA, once you understand one motor, it's much easier to understand another. Number of phases. This shows the type of power supply for which the motor is designed. There are single-phase and three-phase motors. In this example, the number is 3 as the motor is a three-phase motor. Rated operating voltage, volts. This shows at which voltages the motor is designed to operate most efficiently. Motors are designed to operate at plus or minus 10% tolerance of this value. Other parameters shown on the nameplate including power factor, efficiency, torque, and current are at rated voltage and frequency. Using the motor at voltage outside this tolerance will most probably lead to different performance. Service duty. In this case, S1 shows that this is a continuous duty motor that works at a constant load for enough time to reach temperature equilibrium. The parameter duty or time rating represents the period of time during which the motor can run at its nameplate rating or rated load safely and indicates whether the motor is rated for continuous duty. This is shown as CONT for continuous duty 24/7, but they can also have a short time rating from 5 to 60 minutes. Most motors are rated for continuous duty. The rating of the motor is the ambient temperature versus the time it can operate at that temperature. The EIC break this down into 10 ratings. Efficiency code. This shows the percentage of the input power that is actually converted to work output from the motor shaft. The motor will have a nominal efficiency shown on the plate. This is the average efficiency. The closer this value is to 100%, the lower the electricity consumption cost is going to be. The 4 levels of motor efficiency are IE1, standard efficiency, IE2, high efficiency, IE3, premium efficiency, IE4, super premium efficiency. In our example, we are shown an IE code of IE3 which indicating premium efficiency. Frame size. This shows the frame size. The frame size determines the mounting dimensions, such as the foot openings pattern and the shaft height. The dimension of the electric motor based on the NEMA system for fractional HP motors, micromotors, have 2 digits and represent the shaft height from the base's bottom in 1/16 of 1 inch. For large motors, the frame size has 3 digits. The first 2 digits stand for the shaft height in 1/4 of an inch. The third digit is the bolt mounting holes dimension. The longer the motor body, the longer the distance between mounting bolt holes and the base. Finally, the letter is the type of frame. The same concept applies for IEC-type motors, metric motors, but the height is measured in millimeters instead of inches.
Before continuing, 97% from people watching our videos forgetting to subscribe, so subscribe now.
Degree of protection. The IEC uses a 2-digit ingress protection, IP, rating to measure how well the motor is protected from the environment. NEMA uses an enclosure description that is of a similar standard. In our example, an IP of 55 tells us that the motor is protected against dust and protected against jets of water from all directions. Insulation class. The highest temperature in the motor's hottest spot has a serious impact on the life of the electric motor. The temperature that occurs at that spot is a combination of motor design temperature and the ambient temperature. The insulation class shows the motor's ability to withstand temperatures over time. The motors have different insulation capabilities. The insulation codes show their thermal tolerance or ability to survive at a specified temperature for a period of time. The higher the designated code letter, the greater the heat capability. It is based on the highest temperature the material can withstand continuously without degrading or reducing motor life. IES specify 5 different types of insulation classes. Class A, 105 Celsius. Class E, 120 Celsius. Class B, 130 Celsius. Class F, 155 Celsius. Class H, 180 Celsius. In the example, we can see that the motor has an insulation class of F, indicating that the motor's thermal tolerance is 155 Celsius. Temperature rise. Each class of insulation has a maximum motor winding temperature rise and a maximum temperature rating. In addition, a hotspot temperature rise is specified which pertains to motor windings that are surrounded by other windings. Frequency, Hertz. This shows the input electricity frequency that the motor is designed to operate at. Usually for motors, the input frequency is 50 or 60 Hz. If more than one frequency is marked on the nameplate, like our example, then other parameters that will differ at different input frequencies have to be indicated on the nameplate as well. Motor rated power. kW is an expression of the motor's mechanical output rating, its ability to deliver the torque needed for the load at rated speed. Full load speed, RPM. Full load speed is the speed at which rated full load torque is delivered at rated power output. This speed is sometimes called slip speed or actual rotor speed. In the example nameplate, this is declared as minute power of -1, but generally it is declared in RPM. Both these measurements are the same. Rated operating current. This corresponds to the rated power output together with voltage and frequency. The current may deviate from the nameplate amperes if the phases are unbalanced or if the voltage turns out to be lower than indicated. Power factor. Power factor is indicated on the nameplate as either PF or P.F or cos phi. Power factor is an expression of the ratio of active power, W, to apparent power, VA, expressed as a percentage. Ambient temperature. The maximum ambient temperature, AMB, lists the temperature at which the motor can operate and still be within the tolerance of the insulation class at the maximum temperature rise. In this example, the ambient temperature of the motor is 40 C. Service factor. This indicates the amount of overload a motor can handle. Electrical motors are often designed to handle a temporary increase in demand. The ability of the motor to handle these demands are represented by the service factor. For example, a motor with 1.0 service factor cannot be expected to handle more than its nameplate kilowatt. A motor with service factor 1.15 can be expected to safely handle infrequent loads to 15% past its rated kilowatt. In general, it is bad practice to size motors to operate continuously above rated load in the service factor area. Operating a motor at overloads allowed by the service factor for extended periods can result in reduced speed, overheating, decreased efficiency, decreased power factor, all of which affects the overall lifespan of the motor. Altitude. This indication shows the maximum height above sea level at which the motor will remain within its designed temperature rise, meeting all other nameplate data. Below this altitude, the motor may run cooler. Above this temperature, the motor may run hotter. Motor weight. This shows the weight of the motor, 78 kilograms in our example. Serial number. This shows the serial number of the motor. As it is unique to the motor, knowing this number can help when liaising with manufacturers or M&E companies about the type of motor you have.